In this video, we'll look at a couple geometric sequences examples. So our prompt here says, find the common ratio and the nth term of the geometric sequence. So we have 3, 6, 12, 24, and 48. Okay, so to find the common ratio, we have to look at one term and divide it by the term before it. So let's see, that would be 6 over 3 equals 2. And this makes sense, right? We see that 3 times 2 would be 6, and 6 times 2 would be 12. But it's good to confirm that we do indeed have the same common ratio each time. So we get multiplying by 2 each time. Great. So 2 is going to be a common ratio. So r equals 2. And what's our first term? Our first term is 3. So that's our a. And a1 equals 3. Now recall our formula, which was a sub n equals a1 times r to the n minus 1. So altogether, I think we have a sub n equals 3 times 2 to the n minus 1. Now let's just confirm this. Let's write out our first couple terms just to make sure. Just to make sure that we get the same sequence of numbers. A sub 1 equals 3 times 2 to the 1 minus 1, which equals 3 times 1, which equals 3. A sub 2 equals 3 times 2 to the 2 minus 1, which equals 3 times 2, which equals 6. A sub 3 equals 3 times 2 to the 3 minus 1, which equals 3 times 2 squared, which equals 12. Cool. So this works, and this is the rule for this particular geometric sequence. Let's do another one. So we have e squared, e to the 4th, e to the 6th, and e to the 8th. Now, for some cases, our common ratio might not be as clear. Let's take a look at it by dividing any particular term by the term before it. So we'll do a2 divided by a1, which is e to the 4th over e squared, and that equals e squared. Let's do a3 divided by a2, that equals e to the 6th over e to the 4th, leaves us with e squared. And I think that's true as well for a sub 4 over a3, which is e to the 8th over e to the 6th, and that's e squared. Okay, so our common ratio equals e squared, and our first term also happens to be e squared. Pulling this all together, a sub n equals e squared times e squared to the n minus 1. Now, like we did before, let's just check to make sure that this is in fact the rule for this particular geometric sequence. So we'll do a1 equals e squared times e squared to the 1 minus 1, so that's e squared. A2 equals e squared times e squared to the 2 minus 1, so that's e squared times e squared, which equals e to the 4th. A sub 3 equals e squared times e squared to the 3 minus 1, so that's e squared times e squared squared, which would be e squared times e to the 4th, and that equals e to the 6th. Okay, so we've got the first 3 terms of our sequence up above, so I think we should feel pretty good that this is the rule for our geometric sequence here. Now let's look at some sums. Find the sum. So first we need to write this in, we need to find the rule for this particular geometric sequence. So we have the terms 1, 4, 16, up to 4096. So looks like we're multiplying by 4 each time to get up to 4096. And our first term is 1. So our sequence is 1 times 4 to the n minus 1, or in other words, just 4 to the n minus 1. Now, for us to be able to sum this up using our partial sum formula, we have to know what number term 4096 is. So we know that it's some nth term, which means that we're going to have to solve for what n is. So let's plug all this in. We've got 4096 equals 4 to the n minus 1. We don't know what n is. We're trying to solve for n. Now, fortunately, I think we have a couple reasonable ways of figuring out what n is. So we can either try and figure out what 4096 is off the top of our heads, or we can try and figure out what n is by taking the log base 4 of both sides. So log base 4 of 4096 equals log base 4 of 4 to the n minus 1. So log base 4 of 4096 plus 1 should equal n, and n equals 6 plus 1 equals 7. So 4096 is the 7th term of this sequence. So now we can plug this information all into our partial sum formula. Remember, our partial sum formula is S sub n equals a times 1 minus r to the n over 1 minus r. Okay. So plugging this all in, we have S sub 7, because 4096 is the 7th term of this sequence. And this equals 1 times 1 minus 4 to the 7th over 1 minus 4. 4 to the 7th equals 1 minus 16384 all over 1 minus 4. And this equals 5,461. So that's the 7th partial sum of this sequence. Let's do another one. We have the sum starting at k equals 1, going up to 6th of 7 times negative 2/3 to the k minus 1. Now this one's a little bit easier because we have all the information in front of us. Remember, the formula for the nth partial sum is a times 1 minus r to the n over 1 minus r. So we're finding the 6th partial sum because we have 6 up top. Finding the 6th partial sum, our first term, since we'll always have a right there, our first term is 7, and we're multiplying that by 1 minus negative 2/3 to the 6th over 1 minus negative 2/3. And this equals 931 over 243. Now, I did the calculation in my calculator, but you can confirm that.